Today's assignment is 157B, 51 to 85 odd. Okay. The instructions say find the domain of the given function and express the domain in interval notation. There are really only two ways you can restrict the domain by just creating a function. Now, you can go through and say the domain is from this number to this number. You can throw out domain all you want, but the function itself can really only affect it in two ways. There is a third way, but it's sort of related to one of the other ways, and it's not going to come into play today. So what are the two ways you can kill numbers in the domain? We've talked about them a couple times so far. Why can you not plug in certain values? Dividing by 0 and square rooting negative numbers. So if I had something like 1 over x plus 5, every number can be plugged in except negative 5. So the domain would be from negative infinity to negative 5, union with negative 5 to infinity. Right? Okay. What about this? The square root of x plus 4. The stuff on the inside has to be positive. So you could say this, if that has to be positive, let's just say x plus 4 must be greater than, equal to 0, or not equal to 0? Equal to 0 is okay. So now we just solve for x. Subtract 4, x greater than or equal to negative 4. So how do I express that in interval notation? Would be bracket negative 4 to infinity. Okay? What about this? 1 over the square root of 2x minus 18. We kind of have to worry about both of them, right? We're not allowed to divide by 0, and we can't pick x's that make this square root negative. So we know that 2x minus 18 is not allowed to be 0, because if it is, then I get 1 over the square root of 0, which is undefined. We also know that 2x minus 18 can't be negative, so it's got to be greater than or equal to 0. But it can't be equal to 0, so really, if I get rid of this, that equation will cover both the dividing by 0 rule and the non-negative rule. Does that make sense? So I solve this, add 18, 2x greater than 18, divide by 2, x is greater than 9. As long as x is greater than 9, then the bottom will never be 0, and the denominator will never have imaginary numbers in it. We'll never be taking the square root of a negative number. And if you see, if you plug in 9, 2 times 9 is 18, and 18 minus 18 is 0, but it says strictly greater than, so 9 doesn't work, but 9.0001 does work. So the interval notation here would be 9 to infinity with a parenthesis on the left side. Okay. What if it said, does the numerator matter at all? If I had x squared plus 6x minus 3 over the square root of 4 minus 2x, is there anything I'm not allowed to plug into the numerator? What if the numerator equals 0? Is that okay? Yeah, 0 is a real number, and 0 divided by anything other than 0 is also a real number. It's 0. The only time you need to worry about the numerator is if there's a square root in it, because then you just need to make sure that the square root is non-negative. Okay? So in this case, 4 minus 2x has to be greater than or equal to 0, and 4 minus 2x is not allowed to be 0, but I can do both of those at the same time if I get rid of the equals 0 right here. So I can forget this if I just treat this top equation as a greater than 0. Subtract 4. Negative 2x is greater than negative 4. Right, we divide by negative 2, and the rule is, so I get x and 2, but when I divide by a negative or multiply by negative, I have to flip the inequality. Why is that? Has anyone ever explained to you why you have to flip the inequality? Oh, well, let me do it. So, in an equation, we have a balance where everything on the right side weighs just as much as everything on the left side. Okay, so if I have a whole bunch of rocks over here, the amount of weight exerted on that side is the same if I had, I don't know, a bunch of lead. And the rule with equations is I can add or subtract anything I want as long as I do it the same on both sides. So if I wanted to put a feather, that's a feather, on one side, now it's unbalanced, but if I put that same feather on the other side, it remains balanced. Or if I decide I want to take out 10 pounds of this, it will remain balanced as long as I take the same 10 pounds off the other side. Right? So what if I had 1 pound over here, a 1 pound block, and another something that weighed 1 pound? Am I allowed to multiply by something and keep it balanced? If I multiply by 5, that would put 4 more pounds over there, and if I did the same thing on the other side, they're still balanced, right? Okay. Well, this is a little bit weird. What if I multiply by negative 1? What does that do? Well, it turns all of the positive weights into negative weights. So essentially, you flip this 1 pound block into a balloon. It would have to be a really big balloon, capable of lifting 1 pound. So I turn all of my weights into balloons that have an upward force of 1 pound. And this would be a balloon with an upward force of 1 pound. Is it still balanced? Yes. Now, if I were to let a little bit of that helium or whatever's in there out of one of the balloons, so let's say the balloon on the right side, I let some of it out and it stops pulling as hard, it's going to tilt. So it would look something like this. Excuse me. Now, the rules with inequalities are almost the same. But in inequalities, and let's just stick with strictly greater than or less than, the balance is not there. It's never level. It's always tilted in one direction. So if I had this, I had lots of weight here and a little bit of weight there. And we don't care how much more weight there is. We just want to make sure that this side is lower than that side. And as long as that's true, then the answer is correct. Okay? But a trouble comes around when we multiply by any negative number. So negative 1, for instance. So let's say on the left side I had 10 pounds, on the right side I had 2 pounds. What happens when I turn that negative? This now becomes an upward force 10-pound balloon. And on the other side, we have an upward force 2-pound balloon. Do you see the problem? Because it's unbalanced and the right side used to be lower, but when I change the nature of the weights, now it's going to turn the other direction, and it's still unbalanced. But now instead of pushing down, they're pushing up, so the right side used to be lower, but now the right side is going to be higher. So over here, we had negative 2x is greater than negative 4. And by multiplying by negative 2, or dividing by negative 2, which is legal, I've just changed the nature of the weight. They were negative weights, and now they're positive weights. So whatever the balance was originally, it's going to skew in the other direction. So we have to change this, and now it's x is less than 2. How do you represent that as an inequality? Or, sorry, how do you represent that in interval notation? What would the domain be for this? Negative infinity to negative 2. Okay, let me do a quick run through. With a third root, so it's not part of your set, but it's a good thing to look at. Number 72, do we need to worry about creating negatives inside that third root? No, that's not a problem. What about 76? Do I need to worry about creating negatives? Yes, because it's a fourth root. So anytime the root is even, you need to worry about that. And sometimes, let's say I had 1 over x squared plus 1. When does the denominator equal 0? Negative 1 squared is 1, and 1 plus 1 is 2. When does x squared plus 1 equal 0? Well, if we subtract 1, I get x squared equals negative 1. When does x squared equal negative 1? Nowhere on the real number line. The roots of this polynomial are plus or minus I, which are not real numbers. So there is no way using real numbers to make the denominator equal 0, so the domain would be all real numbers. Okay? And I'm not sure what Cynthia does in the back, but if the answer is all real numbers, just use the symbol. She might do this, but we don't need to. Okay, good luck.